are spherical coordinate robot and the articulated robot. Articulated robot is also called giant arm configuration or SCARA, selective compliance assembly robotic arm. Since it resembles to the human arm, okay, the SCARA or articulated robot, it is just like an articulated hand of a human being, so that it is called as articulated robot arm. And the Cartesian coordinate robot, the Cartesian coordinate robot will be developing a work volume in this rectangular form, so that it is also called a rectangular coordinate system. So all these x, y, and z movements will be linear, so that the coordinates of this robot will be represented by x, y, z. That is xyz only. The xyz coordinates, it will be xyz only. Okay, and it is also called LLL robot, or simply you can say it is 3L robot, because along the x, along the y, along the z, linear movements will be there. Since I told you already, the spatial resolution and the accuracy and repeatability are important things, and another one, a control is also important thing. These we have to discuss. Okay, let me discuss the spatial resolution. Imagine that you have been given this cubical or rectangular one small cake you have been given, and you are 10 friends are there. 10 friends can equally divide and eat. That means the work volume generated by these robots are in a rectangular cubical arm, and the spatial resolution of these robots will be equally or uniformly distributed entire work volume of the robot. Entire work volume of the robot will be having a similar size and similar kind of spatially resoluted subsets of work volume, so that we can say the repeatability and accuracy of the robot will be uniformly distributed throughout our entire work volume. Okay, and since this is a linear type, what happens is only the initial and final points are important. In between, how the robot is forming its path is not important. Okay, just at a particular point pick, and at a particular point it has to drop. And what is the acceleration, velocity, and displacement the arm or end effector has to generate, it is not important. Only the initial conditions or final conditions are important. Just like you say, x1, y, x0, y0, z0 is the initial position of the part, and it has to move to xn, yn, zn. Okay, these are the two important points the controller has to remember, so that the controller required for these robots will be very, very simple one. Very, very simple one. And since the movements are just like a frame structure, mechanically these Cartesian coordinates are very, very rigid enough, mechanically stable enough, so that they can be used for heavy part lifting. We can move the parts from one point to the other location, to the one location to other location in the industry. So it is also called as giant robot. Giant robot in the sense it is not giant, it can able to perform heavy work, and most probably in application point of view, it will be used for pick and place, machine loading and unloading, and a simple pick and place operations you can do. Okay, simple pick and place, machine loading and unloading, and helping on the conveyor it will be used, where else very straight motions are required. In between path is not important. Okay, these are the applications of the robot. Okay, and what are the disadvantages? If you want to say the disadvantage, since all are linear, the flexibility of the end effectors is not good enough, so that they cannot be used for other applications like assembly, machine vision applications, testing, and all these they cannot be used. Okay, this is about the Cartesian coordinate robot. I hope you understood this. Next, let me go to, this is what I have written here, and you can go through it, and some of the additional things also I told that you have to remember. I'll write it at the end of this session. And let me come to the cylindrical coordinate system. So during the previous class I had written cylindrical coordinate system. The cylindrical coordinate robots are also called as one L and two, one R and two L robot, RLL. One is rotational and the other two are linear. Okay, one is rotational and other two are linear. The work volume generated by these cylindrical robots are in the form of two concentric cylinders, or simply you can say a segment of a cylinder. Segment of a cylinder, or simply you can say cylinder. Hence, the work envelope, the sweeping of this end effector forms the cylindrical shape, so that the work volume of these robots will be in the cylindrical form, and since these robots are also called as cylindrical coordinate robot. Okay, first one, the work volume generated by these robots will be in the form of cylinder, so that these are called cylindrical coordinate robots. And coordinates are r, theta, z. R is a retracting of the end effector, retracting of end effector, moving front and back. It is R is retracting. Okay, R theta, it is along this vertical limb rotation, and Z is the up and down movement. So that you can say here one linear and two rotational involved. Okay. Next point, what about the mechanical stability? The mechanical stability of these robots will be good enough when arm is not extended much. Okay, just example you can say how much Varun or anyone, how much load you can carry? Any one of you? Any one of you, how much load you can carry? Are you there in the class, Gagan? Gagan, Varun, Shivaprasad, Sumit Kumar Mandal.
Yes, sir.
Yes, sir.
Yeah, you see, your response is very, very important. If you keep quiet, it is forcible. And how much load you can carry? Just I am asking you, anyone. I am not asking sensitively. How much load you can carry approximately?
Approximately on 70 to 80 kg, sir. 50-60 kg, sir.
Okay, 60 kg. Okay. Or you say you can carry flexibly without having much more fatigue. You can carry 30 kgs, for example. And is it possible that you can carry this 30 kgs just by extending your arm? Is it possible? Just I will be giving the example again. This is very, very important. See, during the previous class we did this. See, I'm taking a person, I'm taking a man. Look here, when the arm is extended. So this is when arm is extended. This is a person. This is a person, you say. And you can able to carry the load. You can able to carry the weight like this, whatever it is, 60 kg or 70 kg. Is it possible to carry the load 60 kg here by extending your arm horizontally?
No, sir.
Yeah. And see, in the robotic, it will consider, you can see that when you lift the load like this by extending the arm like this, what happens? The mechanical stability will not be there. The mechanical stability will not be there. The results will be erroneous. The repeatability and accuracy will not be good. See, if I told you to write A here, if I wanted you to write here A, you can write A here. And at the same time, what I'm doing is I'm going to give you one stick in your hand. I'm going to give you a stick in your hand. Okay, it is a stick, you say. This is a stick I have been given you. And I'm going to attach a pencil at the end of this. Okay, I wanted you to write on the board. Is it possible you can write accurately? No, it is not possible. The accuracy and repeatability will not be good once the arm is extended more. You understood my point? You understood? So here also, here
Yes, sir.
mechanical stability of these robots are not good enough as compared to the Cartesian coordinate robot. And you know that the spatial resolution of these work volume of the spatial resolution of the work volume will not be having for the same segment, it will not be having the similar shapes, so that the repeatability and accuracy will not be good throughout the work volume of the robot. You can see here. You can see during the previous class I have shown. See, for the same number of divisions, for 1, 2, 3, 4, 5, 6, for 12 divisions I have done. For the same 12 divisions, the shape of this segmented work volume will be different at the different location. That means to say, the accuracy will be very good at the inner portion of the worker lobe. Once the arm is extended outside, the accuracy and repeatability will not be good enough because of the mechanical stability of the robot end effector is not good. Correct, no? So that what we do is, that means to say, it is not the sensitive, I cannot say. For this, to avoid these mechanical instability and errors involved in this, high level microcontroller will be required. The controller required will be of sophisticated one as compared to the Cartesian coordinate system. Okay, as compared to the Cartesian coordinate system, the controller required will be better than one. And another, since the rotational also included in this, since the rotational joints are there, the independent rotations and flexibility will be more as compared to the Cartesian coordinate systems, so that it can able to remember more points. So it can able to generate a required definite path. Correct, no? So that the controller should have very good one as compared to the Cartesian coordinate robot. And what about the application? The application wise, you see that once we go on add up the rotational joints, the flexibility will be increased and it can able to perform very complicated and complex task it can able to do. So application. So I told you whatever the previous robot can able to do, this robot also can able to do. So this also can be used for a pick and place, a small part or components machine loading and unloading. We can use it. And apart from this, we can use for a simple paint spray and the welding operation. Simple welding and simple paint spray operations, we can use them because one rotational joint is there. Okay, one rotational joint is there. And the accuracy and repeatability will be good along the vertical direction, one below the other. You have seen that. Just like I have arranged the picks, the work volume have been segmented. The shape of the work volume will be same one below the other. You have seen that during the previous class. Correct, no? And next, anything you want to ask me in this, please tell me. And try to prepare here only. Don't keep any time, pending time for the preparation. We'll be having very good interactive time. You can prepare here only. The next one, the same thing I have written here. And let me come to the spherical or polar coordinate system. The spherical or polar coordinate system, the coordinates are r, theta, phi. First one was x, y, z. The second one was r, theta, z. And here it is r, theta, phi. R, theta, phi is the coordinate of the robot. You can see that r is the retraction of the okay, it is not working. You can see that this is this one. It is the arm, it can be extended front and back. It is a retraction r, and this is theta, and this will be z. R, theta, z. Or you can say this as the theta, this as z. It doesn't make a difference. Okay. Since the work volume generated by these robots will be a segment of a sphere, appears to be a segment of a sphere, so that these robots are called spherical or polar coordinates robots. And let me look into the mechanical stability. The mechanical stability of these robots will be lesser than the mechanical stability of cylindrical and Cartesian coordinate robots. Because under an additional rotational joint is involved in this. Since the rotational joint is involved, just now I told you, I have shown you the stability, mechanical stability, repeatability and accuracy will not be good once the arm is extended more. So that here the controller required will be better than or sophisticated than the cylindrical and the Cartesian coordinate robot. And where all we can use them, the application wise, if we say, since the two joints are rotational, we can use them for flexibly can able to use for the assembly operation and very good the welding operations, along with the previous robots what it was able to do. A pick and place it was doing, and it was doing simple welding operations, simple the paint spray operations, and it was doing machine loading and unloading. Along with that, what it can able to do is it can be used for a complicated and very complicated painting and the welding operations. These robots can be used because of only the point is that the two rotational joints are there. Okay, and the mechanical stability of these robots will be lesser than the cylindrical and the Cartesian coordinates robots. So once the mechanical stability is not good enough, then the accuracy and repeatability will not be good enough as compared to cylindrical and the Cartesian coordinate robot. Any points are there to discuss in this? So maximum if you go to any industries that are engaged in the manufacturing, they'll be having specifically the spherical and the SCARA robot. Spherical and the SCARA robot you can find. And another one you have seen the overhead conveyors. The overhead this one will be there. It can the trolley will be there, and by teach pendant they will be guiding, and the whole entire the factory it will be having the railing on the top. That will be just like a Cartesian coordinate robot. Okay, I hope no discussions are in this. Then let me go to the next one. The giant arm robot. Giant arm robot. And to write this, if you feel difficult, even you can use you can write like this also, no problem. I'll be showing you. If you feel difficult to write, you can write like this. Say the different robot the configurations I'll be showing you. And if you feel difficult to write, see, our point is not to write a decorative figure. It is not required. Okay, you have to show specifically what I required. You have to show that. See, look here. The first one, the Cartesian coordinate robot, how it can be shown. I'll show. Very simple mechanism.